Hey Comets, and welcome to this next video. This is going to be on page 2 of the packet you got on March 30th or that week. We're talking about GCFs and the distributive property. So a little bit of review back up to the previous page on how to find the greatest common factor. You're going to need that in order to figure out what we're going to use in the distributive property. So again, this kind of meshes two different standards. Let's look at the example problem. Okay, we got 56 and 35. Okay, so pretend there's a comma here, and you're wanting to know the GCF between 56 and 35. So if you do the prime factorization of 56, you get 2 times 2 times 2 times 7. And if you do the prime factorization of 35, you get 5 times 7. All right, and then GCF is the greatest common factor. Notice 56 has a bunch of 2's, but 35 doesn't. 35 has a 5, but 56 doesn't. The only thing they have in common is 7. And again, this works because 7 goes into both 56 and 35. It's the biggest number that goes into both. Okay? So how do we use that then to do the distributive property? Okay? Well, notice they put 7 on the outside here. So we're breaking this problem into a different problem, where 7's on the outside of the parentheses. And then we ask ourselves, what times 7 gives me 56? And the answer would be 8. And then what times 7 gives me 35? And the answer would be 5. So in other words, we would do 7 times 8 plus 7 times 5 if we're reversing the distributive property, and we'd get 56 plus 35, which gets us back to this problem. The reason distributive property is so confusing is it looks like we're going backwards, right? This looks simpler if we're looking at the order of operations than this does. But that's the whole point, okay? We are reversing the order of operations. We're undoing, we're stretching out the problem and looking at what's inside of it, okay? So let's look at another one together. All right, so we've got 90 plus 27, okay? And if we look at 90 plus 27, we're looking for a GCF between 90 and 27. So I'm going to break down my 90 into 9 times 10, and then 3 times 3 times 2 times 5. Okay? And then I'm going to do that for 27. 27 is 3 times 9. 3 is prime. 9 would be 3 times 3. So I'm looking for common factors here. Okay? Be consistent here. Okay, remember the dot means multiplication. All right, so they both have a 3, and they have another 3, but that's it. Okay, because this has a 2, this doesn't have a 2, this has a 5, this does not have a 5. This has a third 3, but this does not. So 3 times 3 equals 9, so my GCF is 9. Okay, now that's only the first part, right? We want to find the GCF of these two numbers. Then I want to use that to separate them by putting a 9 on the outside of my parentheses. Okay? And I'm going to ask, what times 9 would give me 90? Okay? Well, the answer would be 10. And then what times 9 gives me 27? The answer would be 3. So again, 9 times 10 gives me 90. 9 times 3 gives me 27. So this is my answer, all right? Because even though this is simpler than this, right, I'm undoing this problem. I'm pulling it out. I'm factoring out the greatest common factor, 9, and then what would be left over if I took 9 out of 90, and then 9 out of 27, or divided it out. Okay? So it's kind of a different way of looking at things, all right? Now, there's a couple other problems at the bottom of this page I'm going to look at before I end the video. Okay, these are the stretch questions. My advice to you is to look at the situation and ask yourself, is this GCF or is this LCM? Because the approach is going to be completely different depending on which one it is. Okay, and GCF is usually talking about dividing things into groups, all right, separating them into equal groups of things. LCM is kind of predicting or projecting out into the future, okay? So see how you guys can do on these, and maybe in a future video we'll go over them and see how you did. All right, thanks for watching.